Okay. So, homework okay? No big deal? I know some people were using the Windows version, which looks substantially different than the Mac version, but you were still able to pull it off on there. Not a big deal. Remind me, so we go back to the very beginning about how human beings solve problems. We use our memory, we ask questions, and we use repetition. Programming languages typically provide these tools for us through variables, conditionals, and loops. How does Gamesalad emulate variables for us? Go ahead.
As actors?
No. Not as actors. Go ahead. Attributes. So built into Gamesalad, we have this idea of an attribute, which is our ability to remember things over time. Okay? And for your homework assignment, you were to create an attribute associated with your blueprint, maybe called text to display or something like that, whatever you wanted to call it. And that attribute would hold the value that you ultimately want to display on that actor. Then we added a display text behavior to our actor that instead of having a hard-coded value, hello world or something like that displayed, we told it to display whatever is in that variable. That makes sense? So if we go back here, right now we have cat and hello. The original prototype had cat, but we had made a modification to this guy to display hello. If I click revert to prototype here, notice that hello stayed. Okay. Oh, we're in the game right now. There we go. So I can change attributes associated with an actor without giving up the behaviors that I inherited from my prototype. All right, so this allows us to create situations where we build the prototype which has everything in it that we want to have for a particular actor, but through attributes we can differentiate one actor from another. Make sense? Now, last time we mentioned the idea of maybe in a video game you might have like a boss fight where you have an actor who's kind of based off of, maybe the boss actor is based off of the guys you've been fighting all along. So in that particular case, you might open up whoever's going to be the boss, and you might choose to unlock this guy so that you can deviate from those default behaviors. Maybe he's throwing ninja stars and stuff like that, I think is the example I use. So the boss is a little bit more dangerous than your average white box, I guess, in our current game. Okay, so in any case, what we talked about last time is how do we emulate variables in Gamesalad memory, and we do that through attributes. All right, now we have a couple of different ways that we can do this. Last time what we did is we looked at attributes associated with an individual actor. Okay, so this gets us into this concept called variable scope. Variable scope. Scope means where can we access a variable? Okay, that's all it means. Where do we have access to that variable? Or in Gamesalad, that attribute. Okay, I typically will use those two terms somewhat alternatingly, close enough. That way both of them are in our vocabulary, because when we transition to Java in 250, the next class, we won't be calling them attributes anymore, we'll be calling them variables. So we want to reinforce that connection. Okay? So variable scope is where we have access to a variable. And what drives this is where we define the variable. Or you might say, or who owns the variable. And we'll look at this through an example here. All right, so for example, in Gamesalad, and let me just go ahead and take our second actor away. So we're going to rename this blueprint. We're going to name this guy Actor 1. Okay? We're going to create a second actor. And this guy's going to be called Actor 2. And we're going to make this actor a different color. Is that pink, hot pink? Yeah, he's the hot pink actor. All right. So we have two actors, Actor 1 and Actor 2. In Actor 1, we added an attribute called text to display, right? And this guy we defaulted to cat, and then we added a behavior that shows all Actor 1, every copy of Actor 1, every instance of Actor 1 shows his version of the text to display variable, his version of the text to display attribute. So by default, every Actor 1 we create will show cat, because that's the default value that all of them were given for that attribute. Make sense? We can then go in and we can change it for an individual actor to be something else. And we've seen this. Okay, so I changed one of those guys. So now we have two cats and a dog. Make sense? Now, what I'm going to do is I'm going to throw the pink actor out here on the screen. Now, when I hit play, what's going to show up? Well, we already saw we have two cats and a dog over here. What's going to show up on this guy?
Hello.
You think hello world? Why? Okay, I didn't change it. Any other guesses? I haven't done anything with this guy. Even though these guys look the same. Actor 1 is one blueprint. Actor 2 is a separate blueprint. And what did I do? I went in and just made Actor 2 the color hot pink. That is a hot pink, isn't it? It's one of my favorite colors. I have a hot pink shirt. You guys seen me wear that one yet? Must be my Tuesday, Thursday shirt. Actually, I think I wore it yesterday. One of my favorite shirts. Okay. So, when we go into our Actor 1, that blueprint, we see that we already have a behavior in here. We put this behavior here. We also went over here and we created an attribute. Now, when we go into our blueprint for Actor 2's, we see that there's no behaviors over here. No additional attributes other than the ones it came with. Okay? So at this point in Actor 2, does nothing. It's a pink box. That's it. Okay? Now, if I want to add a behavior, I can come in here, find the display text behavior down here, drag it over here. Now, by default, this guy will now say hello world, right? Now that I've given him a behavior, I've taught this guy how to do something. And it's just going to print out the hard-coded hello world, and the default color is white. That'll probably show up on pink, I think, all right? All right, so there's hello world. So makes sense that this is one type of actor, this is another type of actor. Okay, we have three copies of Actor 1 who all act the same, except one guy, we changed his attribute. We have another guy who's an instance of Actor 2, who only knows how to display hello world. Now remember, what we're getting at here is this idea of variable scope, that is, where a variable is accessible. We defined a variable inside of Actor 1. So we can access it anywhere inside of Actor 1's. So in our three Actor 1's, we had access to this variable, called text to display. Now, when I come into Actor 2, if I want to make my hello world be something a little bit more dynamic, I'll click on the expression editor. we'll click the drop down just like we did for actor 1. We see, well, first of all, we don't have actor 1 available to us here. Okay? He's somewhere else in the scene, somewhere else in the game. But actor 2 does not have a text to display variable. Okay, so the variable I created in actor 1 is local, only accessible to actor 1's. That's its scope. Okay, it's not accessible in actor 2. Does that make sense? I can create another variable in actor 2. We'll make this guy type text. And we'll even name it the same thing. Text to display. Is that how I named it? Same. Okay. And we'll make this guy be elephant by default. Okay. So now when I go to my expression editor, I'll go down and I'll find actor 2's text to display, which shares a name with the same attribute in actor 1, but they have nothing to do with each other. I just happen to name them the same thing. Okay, one of them is a local variable to actor 1's, the other one's a local variable to actor 2's. Okay, so this allows things of type actor 1 to remember stuff and things of type actor 2 to remember stuff. So now we'll see that all of these guys show elephant. Go ahead.
And now we have here the actor 1. If you had one more, is it going to show dog or cat?
Well, you tell me.
I guess.
So let's. You think cat?
Yeah.
Okay, why?
Because you changed that manually.
Okay, so this is the prototype for it, right? So whenever I build an actor 1, I'm using this blueprint to build it. I changed this guy manually. After I built that house, I went in and changed the color of the paint in the bathroom. Make sense? Person didn't like the color of the paint. So for this particular one, I changed that value. But all the other ones were built with the blueprints values. So if I go in the blueprint for actor 1, I see his text to display is cat. So that means for every single actor 1 I build, following that blueprint, it'll be cat. Make sense? So here, I'll drag another one out here. Now we'll have 3 cats and a dog. Okay? Now, what if I want both actor 1's and actor 2's to display the same value? Well, as we're currently looking at it, we might just say, well, just make sure you set the text to display for both of those to the same value, right? Well, that becomes problematic in and of itself, because now if we want to change the value for one, we have to go and change the value for the other. We have to change it in 2 places, even though we actually want it to display the same thing regardless of which of those 2 actors. Okay, so we need to go back to this idea of variable scope. Now, right here, we are at the game level. Okay? We also have something called the scene level. And let me show you this here. When we are in actor 1, for example, and I go to our expression editor, we drop down. Notice that in here we have access to the actor. So we have access to all the attributes associated with us. But we also have access to attributes associated with the game. Okay, so we can think of the game as kind of the global repository of memory that all actors in our game have access to. Make sense? So the idea here would be if we go to our game level, we'll talk about scene later, but if we go to our game level and I go to attributes and I add an attribute of type text, and we'll call this guy the same thing, text to display, and we call this guy rat. Okay, so now we have a global variable, that is a variable at the game level, that every actor in the game has access to. That means the scope of this attribute is throughout the entire game. All right? So now I can go to my actors, go into actor 1, and instead of having this guy display his text to display, I'm going to modify this and say I want to show the game's text to display. Okay, this global variable. Similarly, I'll go into our actor 2, and I'll also tell him to display the game's text to display. Now I run this, and we get a bunch of rats. Make sense? Because they're pulling from this global variable. Now, if I decide I don't want it to say rat anymore, I want it to say something else, I can go to my game, go to the attributes, change text.display to, I'm running out of animals, to bat. All right. Now when I run the game, we get a bunch of bats. That make sense? I was able to change it in one place, and it had a global effect to everything that accessed that variable. All right. Kind of understand the concept of variable scope, where we have access to it. Now, in terms of defining variables, one might just think, well, you know, for ultimate flexibility, why don't we just define all of our variables at the game level? That way I'll never run into a situation where I can't access it, right? We'll just make everything global so it's all out there. Well, that might be the easy way of going about it, but now you've created some, well, first of all, there's a good rule of thumb in programming that global variables are bad. I would say, generally speaking, global variables should only be used when they're necessary, and we're going to find several situations here in Gamesalad where they are necessary. But global variables should not be the default. You want to make variables as private as possible, as compartmentalized as possible, so that they solve the problem you need them to solve and nothing more. Don't make it more flexible unless you need it to be more flexible. Kind of make sense? Okay. Now, I kind of mentioned a second ago about this idea of sometimes Gamesalad forces us into this idea of global variables. How many of you have seen the Matrix movies? Everybody in here hasn't seen the Matrix movies? Just one of them. Hopefully, was it the first one?
Yeah.
And you didn't watch the other two? Can't you like just go on to the internet and accidentally watch the Matrix movies now?
Yeah.
For technologists, that's like, you have to watch the Matrix movies. It's like our modern day Star Wars trilogy. It's killing me. Well, at least you saw the first one. So in the first one, Morpheus, when he was fighting with Neo, when Neo was first learning how the world worked, Morpheus was talking about that he was constrained by the rules of the world, right? So Neo had to solve problems when he was in the Matrix in terms of the rules that were put on him by the Matrix. Okay. Well, in real life, we have certain things that we are going to find difficult to overcome. Okay, for instance, gravity. We don't just fly away because gravity's pushing down on us, right? Okay, there's several other examples of that. For instance, I'm not just going to be able to go that way indefinitely. I'm going to start running into walls. I have to kind of go through openings in order to snake my way through the school. Okay, so we have to play by the rules of our environment. Same thing is true here. Gamesalad puts some limitations on us. And as we try to do gamey type things, we're going to run into some limitations that Gamesalad might put on us. So we're going to have to come up with interesting ways of getting around those limitations. Given how few of you said you saw The Matrix, this follow-up question is I'm going to get depressed by this one. How many of you are familiar with the TV show MacGyver? 4.5 people. How many of you are familiar with the phrase, I MacGyvered this? Okay, more people. Okay, that's based off of a TV show. Okay, so the idea of the MacGyver show is This guy, every episode, and it was always actually kind of ridiculous. He would get caught in some situation, and he had to build something out of nothing. Okay, so like one time he was chained up in somebody's garage or something, and the guy built an airplane out of like a lawnmower engine and I don't know, a toilet paper roll and like a spare tire or something, stuff like that. So the idea is he had to solve problems in terms of the crap that was just laying around. All right, so sometimes in Gamesalad, we have to MacGyver solutions because we have to solve problems in terms of the tools Gamesalad has given to us and the problem we want to solve. And part of that is because of our decision to use Gamesalad. Typically, when you use more powerful tools like this, tools that do a lot of the work for you, they had to make decisions that took certain choices out of your hands. So when we make our games with Gamesalad, we don't have the flexibility that we would have if we were making our games from scratch using a modern language like Java or C#. Well, the trade-off is in Gamesalad, in just a few seconds, we could have a whole bunch of actors on the screen doing stuff. In C#, that's like several hours of work to get one guy on the screen doing stuff. Okay, so solving a little bit of a different problem, while solving the same problem in a very different way. Okay, so something we will run into. All right, so that deals with variable scope. So let's get rid of a bunch of these guys here. All right, now, just as we built some variables into the game and into our individual actors, there's also a whole bunch of variables that already exist. A bunch of attributes that already exist as part of our actors. So one of these, if we go down here to the bottom, we have physics, motion, and graphics. So graphics, we can decide whether something is visible. We can decide all these other modes associated with it. We can flip it horizontally and things like that. We'll mess with all this stuff. So graphics is how it looks. Motion is how it moves. So we have something called linear velocity. And this is on the X and Y coordinate, just like in your math classes. So X goes left and right, Y goes up and down. All right, so if I set the linear velocity on X of this guy to 100, and I did that to the blueprint, now I run this, all of our actor 1s move at a speed of 100 to the positive side on X. That makes sense? And that's at the blueprint level. So I can put multiples of these on the screen. Okay, and all these guys will just start trucking as soon as I hit play. That makes sense? Okay, similarly, if I go in and I change the blueprint to be negative 100, now they'll go the other direction. Let's set it back to 0, and let's set it to 100 on the Y. So positive on the Y goes up. Negative on the Y will go down. Okay, notice that they're gone. Okay, they're still flying off the screen here. And if we think about that from a video game perspective, they're somewhere out there in the abyss right now. But are we having to use graphic processing power in order to show them? They're not on the screen. We only care about the window that's in front of us in terms of using our graphics card to display stuff. All right, stuff that's happening off the screen is kept track of. The stuff still exists until these actors are destroyed. But we don't have to deal with the overhead of actually showing them because our view of the world is through this little box. Make sense? Okay. Now, if we were to give a name to Gamesalad, we would call this guy a game engine. Okay? Game engines provide mechanisms. Spell it right? Yeah. Provide mechanisms for displaying images handling physics let's see, and designing levels for games. They have all these tools built into them. Okay? And probably the big thing for most game engine or game designers is the idea of the physics engine. Okay? The thing that simulates gravity. Right? So in a video game, more realistic games have a realistic feel to how you think something would happen in the real world, right? So if you're playing Battlefield, one of these realistic war simulation type games, and you're running around and all of a sudden your guy just starts floating up in the air, that wouldn't feel very realistic, right? You just hit the anti-gravity zone. Okay? Well, Battlefield is supposed to be kind of real life type war. Now you're playing Halo or another maybe alien-y type of thing. Maybe hitting an anti-gravity zone is more reasonable. Kind of make sense? Okay? But the idea is that we rely on these things to add some realism to our games. Well, the physics of video games is difficult. We're not just talking about gravity. What about when we bump into stuff? How many of you have ever been playing a video game and most games have part of the game is to avoid stuff, that you don't run into it, right? How many of you just absolutely swear that you didn't bump into that thing, but the game says you did, right? There's no way I hit that. My brother used to hold up his controller. Says, look, I pushed that button. And I used to think that was pretty good evidence. Okay, so in any case, we've all dealt with that, right? So part of physics is dealing with collisions. When do two objects run into each other? Well, you got to keep in mind that when we're dealing with our games and we have these pictures on the screen, what we see in the picture may not be what's usually called the hitbox of that actor. So if I took our actor over here, this guy that looks like this, and let's go out real quick and let's find a Super Mario Bros. Let's find a Mario. Are we going old school Mario or new school Mario? Looks like we might be forced into new school Mario. We're going new school Mario. So here's Mario. So we want to go ahead and steal Mario. So download him off the internet. All right. And then we're going to go into Gamesalad here. We'll go to Images. And we're going to import this image into the game. So I stored it in Downloads. And there's my Mario. We'll rename this to, sorry. I think I can rename it, can I? Maybe not, doesn't matter. So now I'll go to Actor 1. Go ahead and double click on this guy. And under Attributes, we have something called Image. Now, Image allows us to set the image for this guy. Now notice we have this thing that says drag image here. So it shows us our images down here. And I can drag Mario up here, and there's Mario. All right, so now we got a bunch of Marios in our game. Now right off the bat, we start seeing, well, first of all, we still see the word bat. Probably take that off now that our actor has some look to it, and let's also maybe get them to stop moving temporarily for us. So we'll set the velocity back to 0. And we will, that's not the text to display. Let's just remove this rule. He's not going to display any text anymore. So at this point, our actor is just a picture. That's all he does. Sorry, I keep checking that. There's a delivery coming to my house, and I need to let my wife know when it's arriving, and they're supposed to text me. Okay, so here's our Mario. Now, as we were watching this go, if we were playing a game, we see where the person Mario is on the screen, but isn't there a whole bunch of white space around him right now? Okay, so what I'm going to do here is I'm going to actually modify our image, doing it kind of maybe a simple way. So I'm going to come here to, actually, let's just do this. Can I do it within Gamesalad? I might be able to do this in Gamesalad. Let's find out. Okay, so I double-clicked on the image. It opened it up for me in preview. And I'm going to go, and we have a bunch of tools available to us. Nope, that's not what I want. Here we go. Why don't I have access to my tools? Okay, well, I have that guy. Should have a tool here that, oh, here we go. I had to click on that guy. So inside here we have this guy that's a magic wand. And what you do with this is it helps you select the magic wand, you just pick an area, like in this case I'm just picking the white area. And when I click and drag a little bit, it tries to select all the areas that match that color. Okay, rather than me having to go through and granularly, draw a line around them. So it kind of gives me an easy way to just cut Mario out. All right, so I did a pretty good job. We got some corners in there, but we'll say this is good. All right, so there's Mario. All right, so that's our current version of Mario. I'll go ahead and save this. And is it going to let me, here we're just going to say this guy, we'll call him Mario. It doesn't look like it changed it in here. So I'll go ahead and remove that version of this guy. And then I'll bring the new version in. I put him on the desktop and called him Mario. All right. So we'll go ahead and drag Mario up here. So now we see Mario looks somewhat not legit, but significantly more legit on the screen, right? Okay. Now, the reality, though, is if I double-click on this actor, and we go to his size is still 100 by 100. So even though we have this picture that looks like Mario out here, he is actually shaped like this. The bigger box. Okay? We just happen to have thrown a sticker on that guy and said this is what we want people to visually see, even though the actor itself is still a 100 by 100 square. Okay? And let's go ahead and drop it down to just have one Mario on the screen. Get rid of some of those guys. All right, so there's our Mario. And we'll go ahead and drag our actor 2 onto the screen. And we'll go into actor 2. And we're going to go ahead and make this guy travel towards Mario. We'll have Mario stand still, and he will just immediately have we'll call this a pink fireball flying towards Mario. We'll give it some nice graphics if we have a couple minutes here at the end. Okay, so I want to make him travel to the left at a speed of 100. So where do I go to do that? So I go to motion. I go to linear velocity. Am I doing this on X or on Y? X, and negative 100. We'll make that go to the left. All right. And we'll go ahead and hit preview, and we'll see the bat is flying towards Mario and goes right through him. I can tell you, Mario definitely got hit by the bat, right? But nothing happened. Why? Remember, we get back to that original question. How many of you got to class today without bumping into any walls? Most of us did. And we did that by constantly asking questions. Well, in our game here, we created a couple of actors, and we told them what to do. Well, we told Mario just to look pretty. Okay, that's all he does. But we told our hot pink actor 2 to travel to the left at a speed of 100. But we didn't teach them how to ask, am I going to hit something? That makes sense? So now what we'll do is we're going to go into actor 2, and we're going to look at how do we ask questions. Asking questions. In Java, we do this through conditionals. In Gamesalad, we do this through rules. So the Gamesalad version of a variable is called an attribute. The Gamesalad version of a conditional is called a rule. Now, have we talked? Okay. Now, in order to ask questions, we first need to learn about Boolean expressions. We haven't talked about those yet, right? So just like we discussed with variables, we learned about our various primitive types built into our modern languages, and then we've seen there's a subset of those as far as our attributes in Gamesalad, of which we've only used text at this point for displaying some stuff. We have this idea of a Boolean expression in all programming languages, including Gamesalad. A Boolean expression is any expression that boils down to a single value of true or false. Okay? So for instance, a Boolean expression would be, am I going to hit the wall? The answer is either true or false, yes or no. If the answer is yes, I might choose to do something about that. If the answer is no, maybe I just kind of keep on course. Make sense? So, Boolean expression is any expression that boils down to a single value of true or false. We use Boolean expressions to create conditionals, to create rules. Okay? So in Java, a conditional is written with the word if, some Boolean expression, opening curly brace, true statement, closing curly brace. Then optionally, we can have an else, opening curly brace, false statement. So if this Boolean expression is true, do this. Else, if it's false, do this. All right? And the else is optional, just like our example of walking down the hall. We might say, am I going to hit a wall? Or if we're going to ask it in Java, if I am going to hit a wall, change my course. Turn left. Maybe we start off by just stopping. Right? Stop and reevaluate. Make sense? Now, let's say that somebody is, let's see. To have a good example of do one thing versus do another thing. Okay, here, we'll do this with eating since we're close to lunchtime. So, if I am still hungry, pick up the fork, take another bite of whatever you're eating. Else, put the fork down, put your tray away. Make sense? Okay, we have two things we're going to do there. We're going to ask the question, am I still hungry? If I am, I'm going to take another bite. If I'm not, I'm going to put my tray away. Okay, so two different actions depending on the answer to my question. All right, so that's where the else is optional. In other cases, like when I said we're going to bump into a wall, if we're not going to bump into a wall, we just leave well enough alone. I don't need to act, right? Just keep texting or whatever it is I was doing. All right, so we have the arithmetic Boolean operators. And we're all familiar with these. Those are less than or equal to, greater than or equal to, and not equal to. Okay? So, certainly, we've all seen these. Less than or equal to, greater than or equal to. So 5 less than 7. True statement, right? It is true that 5 is less than 7. 5 less than or equal to 5. Also a true statement. It is equal to 5. Is 5 less than 3? No, it's a false statement. So let's look at some examples, potential examples of Boolean expressions. So can I say 5 less than 7? Is that a Boolean expression? What's a Boolean expression? Any expression that boils down to a single value of true or false. So what's the answer to 5 less than 7? It's true. Is that a Boolean expression? Yep. 5 less than or equal to 5. What's the answer of that? True. It's equal to it, so it is true that it is less than or equal to. Is that a Boolean expression? Yep. 5 less than 3. What's the answer of that? Is that a Boolean expression? Yeah. Sure, it was false, but it was still a single value of true or false. Make sense? All right. Is that a Boolean expression? Are you submitting both answers? Yes and no. What's the value of true? What does that boil down to? Up here I asked you what did this boil down to. You said that 5 less than 3 boils down to false. What does true boil down to? True. Just like 5 boils down to 5. Right? These are literals. This is a hard-coded value, a literal. It's built into the language. So true boils down to itself, which is true. 5 boils down to itself, which is 5. Now, if I defined an integer, a is equal to 5, and then I said a will boil down to the value it holds, which is 5. Make sense? Now, having said that, is this guy a Boolean expression? Why? It boils down to a single value of true or false. It doesn't look that expression-y, but in fact, it does boil down to a value, and that value is a single value of true or false. So it's a Boolean expression. Make sense? Similarly, false, Boolean expression. All right. So these are our arithmetic operators. Then we have our logical Boolean operators. Logical Boolean operators in Java, we have double ampersand, which is the AND operator, double vertical bar, which is the OR operator. We'll actually just leave it at that. That'll be good enough for what we're going to do in here. There's actually this and this and this in Java. This is what's called the bitwise AND. This is the bitwise OR, and this is the exclusive OR. Bitwise is solving a different problem. It deals with ANDs and ORs at each individual bit in a number. So you would do a 5 and 7, and it would give you an answer based on the binary version of 5 compared to the binary version of 7. Unrelated to what we're doing in here. So we're just going to focus on these two. Okay? For an AND to be true, both sides of the AND must be true. For the expression to be true. For an OR, at least one side of the OR must be true for the expression to be true. For example, I could say something like 5 less than 3 or 7 greater than 5. 5 less than 3 boils down to what? False. 7 greater than 5 boils down to what? True. 7 is bigger than 5. So this is false or true, which is what? True. Because at least one side of the OR was true. If I change this to 5 less than 30, now we have a true or a true, which is still true. 5 less than 3, 7 greater than 50. Now we have a false or false, which is false. Make sense? So for an OR, at least one side of it must be true in order for the whole thing to be true. But ultimately, is this a Boolean expression? Sure, it's more complex. We have, this is a Boolean expression, this is a Boolean expression, and this entire thing is a Boolean expression. Why? Because it boils down to a single value of true or false. Okay? So when you see an expression, you can't automatically assume that this is not a Boolean expression because you see numbers. Okay? Or it's not a Boolean expression because you see a whole bunch of stuff. You have to go through and boil it down to its actual value. You have to resolve the expression and see what kind of value comes out in the end. And if it's a true or false, then that guy was a Boolean expression. Make sense? Okay. So next class, we'll come back and we're going to start looking at rules in Gamesalad, which is our ability to ask questions. I'll see everybody on Friday.